Hi, everyone. Quick test. All right. Testing audio. Okay. All right, everyone, take a seat. It is time for lecture 13. It's Wednesday. All right, so today we are going to do conditionals, iteration, and we'll actually start with a little bit of sampling, then you'll do more sampling and get into the whole simulation part of this class starting on Friday. So it's a pretty exciting week. We have a first announcement before our main announcements. So Professor Harding is here from sociology to give a quick update on a survey we're running.
Okay. Good morning, everyone. Thanks for having me. I'm here to ask you for your help. So as you may or may not know, the Berkeley Undergraduate Data Science Education Program is a national model. Universities, colleges from across the country and actually around the world are replicating Berkeley's data science education programming, especially this course. And in recognition of that, the National Science Foundation has given us, the faculty here at Berkeley, a grant to study and continuously improve our program, okay, so that it stays at the top and so that people who are replicating what you guys experience get the best possible program. Of course, the best way to know how well the program is working is to hear from you guys, the students who are in the program, learning in the program. And so what we're doing is we're trying to do, well, we're doing two surveys, one at the beginning of the semester now and one at the end to hear about your experiences. It'll take you about 10 minutes to complete. You can either use the QR code or the link here in the slides. You should also have an email from ucbsurveys@berkeley.edu asking you to do the survey, completely anonymous. Only the people on the research side of the project will see your responses, not your actual faculty or other instructors. To thank you for your time doing the survey, you can either choose a $5 gift card from Amazon and just take that $5, or you can roll the dice and enter in a drawing to get one of 8 $50 gift cards. So your choice on that. So we really appreciate your help if you could do that sometime in the next week. And yeah, and that's it. Thanks for your time.
All right, thank you. Yeah, I should definitely do that survey, and maybe we should do as an exercise in lab which one is the best outcome for $5 or the $50. So it sort of depends on how many people decide to do the survey. All right, QR code link is there. The lecture should be posted on the course website, so you can also get the link directly here. Let me do one thing. I'm on Wi-Fi, and that has the risk of failing. Yeah, I'll leave it be. All right. Okay, so other announcements. So this is similar to what we announced on Monday. Homework 4 is due Wednesday, 15. So next, that's today. Wow. Okay. Yes, homework is due today at 11 p.m. Project 1 is due the 24th, so a bit away. But the checkpoint, which is intended to make sure that you don't try to do the whole project the night before, that checkpoint is due this Friday. So keep that in mind. Try to get stuff together for the checkpoint. Midterm accommodations form has been posted. It's really important you fill this out. It's how we make sure you have seating. You know, people need room on their left side or the right side. So please fill this form out as soon as possible so we can make sure we can accommodate everyone for the midterm. Yep. The form? There's a 404 error for which link? Oh. Oh no. I broke the demos. They should be in Git. Okay, so there's a 404 error for the demos. I don't have a quick fix for you right now. If we have a pause in a moment, I will look into that. I did push the demos, so it might be just a link on the website. Okay, I think that is it for, oh yeah, my office hours from 1:30 to 3 at FSM. No one comes to my office hours, so I feel sad. It's in the very back. You don't have to have a question. You could just come and say, hi, how's it going? I like data science. I don't like data science. Here's how I think the class could be better. Here's what we should keep. All that stuff is great. So you don't have to come in with the question. And if this location doesn't work, I have a sad Ed post about how no one showed up. So maybe post that like, yeah, I don't like that location. We'll find a different place to meet. I'm trying to get some shade is in the sun, but not too much sun. We could just also meet in my office, which is also a little sad, but that could work too. Okay. Announcements. All right. So today's lecture, a mix of different topics. We're going to go back to some basic Booleans, comparisons, operations on Booleans. Then we're going to bring in the if statement and the for statement, two very powerful things in Python that we'll use to express more complex programs. And then we'll try to connect these with various exercises along the way. Booleans. So we've already been doing a little bit of Boolean operations. Maybe one of the things that's a little bit confusing, or maybe have we done equality? We may not have done these operations yet. So let me go through this in two parts. So we've been doing these things up top, like x equals 2 or y equals 3. Those are assignments. That is where I'm taking a variable x and saying the value of x should be 2, and the value of y should be 3. These things on the bottom here, like x equals y, is not an assignment. It's a question. Does x equal y? Are they the same value? So this evaluates to a true or a false. These might make more sense. So x is greater than 1. It's not an assignment of x, it's a question. Is x greater than 1? And again, it would evaluate to true or false. These are Boolean expressions. Just a quick overview of these, and we'll go into some examples. So x greater than 1 is x greater than 1. Is x greater than y? Just comparing, I can compare numbers, I can compare variables. They have to be things that are comparable. So we'll come back to what that means. Equality, so greater than equal to 3. If I want to do less than, I would do less than, or if I want to do less than and equal to, I would write the less than sign and equal to 3. Direct equality, is x equal to y. This one's a little bit confusing. What is this? Not equals. So x not equals to y. So this will be true if x doesn't have the value of y. And then Python's kind of cool. It lets you write these, more compound expressions like 2 is less than x is less than 5. And that whole thing will be true if x happens to be greater than 2 and less than 5. Okay. Boolean expressions, pretty straightforward. Demo time. Maybe I zoomed in too much. That looks good. Okay, so this is the notebook. Were we able to fix the link? We're fixing it. I'm sorry that the notebook is not there. So I sometimes try to do my own posts And sometimes maybe I use the wrong URL. I should ask the staff who know what they're doing to do that. All right, so here's the notebook. It will be posted hopefully soon. The first steps here, I'm going to just walk through some simple expressions. So 3 greater than 1. What will that evaluate to? True. Let's try it. True. So it returns true. What is the type of 3 greater than 1? Boolean. Very good. What is the type of true? That seems redundant. Okay, it's also a Boolean. So we've been doing some basic Boolean expressions. Just to be, here's an equality statement. So is 3 equal to 3.0? Hope so. It is. There are some subtleties when we have decimal numbers and equality, but for these integral values, I think we'll be fine. So that is true. Just to drive this point home, if I were to do something like 3 equals 3.0, what is that? That is an error, right? So I can't say set the value of 3 equal to 3.0. 3 is not a variable. Inequality, it's just not equals. So 10 exclamation is not equals 2. 10 does not equal 2. That is true. All right, so it's pretty straightforward. Let's try to make it more interesting. All right, so we have 2 variables, x and y. So is x greater than 15? False. Is 12 greater, or is 12 less than x? True. Is x less than 20? This is getting repetitive. Well, is x less than 20? That is true. All right, so now let's do some more interesting expressions. So we can do these compound expressions. So I can say, this is like what you might see in like a math assignment. So x 12 is less than x is less than 20. What is that? Is that true? Yes. Can I put like 10 here? False. Okay. So that's a simple expression. Another way to read this, and I'm now going to introduce a new piece of syntax, is this is really, there are 2 things happening here. I'm asking, is 12 less than x? That's one thing. I'm also asking, and x is less than 20. So I'm combining 2 Booleans with an and. We could also write or to combine 2 Booleans, right? So is this true or is this? And so if I put or, and I say this is less than x less than 5, true? I'm going to make this and, true? False. Okay. Boolean expressions. We can do interesting stuff like, here, I don't know the answer to this, x minus y less than 13. Quick, someone do math. Is that true? I don't know. Shift enter. It is true. X minus y. What is x minus y? What's the value of x minus y? X minus y. It's 11. 11 is, 10 is less than 11, which is also less than 13. Okay. Any questions? Booleans are, this is nice, gentle startup lecture. Yeah. Is line, one more time? 14. So I valued 14. So the way to read this is it's 12 is less than x and x is less than 20. Okay. There's a way to make this confusing. I'm not going to talk about it. All right. Any other questions here? Return to slides. Yes. Oh, you have a question. That's great. No problem. Did I not push the demo? My apologies. I forgot to push the demo. Please try the link again. That's really embarrassing. yeah, for you didn't see what I was doing online. There was some stuff. Don't worry about it. Okay. Back to slides. Does it work now? Whoever's looking at the demo. Okay. All right. Aggregating comparisons. Okay, now we're gonna get creative here. So we have Boolean operations. They are either true or false. We can actually do math on these Boolean operations. So if I have an array of Booleans and I sum them up, what should that do? What does that mean? Well, this is computer science. So true is also known as 1, and false is also known as 0. And so I can think of my array of Booleans or my collection of Booleans as just 1s and 0s. And I can do math on my 1s and 0s. And Python will be totally okay with that. So here's an array of 1s and 0s. I have 1 plus 0 plus 1, that is 2. That is equal to 2, so that is a true statement. But I can also say true plus false plus true is equal to 2. That is also a true statement. We've already seen this in lecture, so I can take some of my, this is a list, I can take sums of arrays and lists, and they'll behave the same way. And likewise, the sums of arrays and lists, sums of arrays or lists of Booleans will behave just like 0s and 1s. Demo time. All right, so I have an array here called pets. All right, so the first thing we're going to do, and this is, I guess I didn't cover this in the slide, pretty important. I can take something like an array here, this is pets, and say, is this array equal to cats? Which is kind of a silly statement, right? Because it's an array. So what does it mean array equals cats? But Python's like, well, I want to try to make sense of that. And the way I'll do it is I'm just going to take cat and check each element in the array and see is cat equal to that element. So it does an element-wise operation. Questions? It's a little weird. Sort of like when we took an array of numbers and then added like 6 and then said, well, okay, I can't add 6 to the array, but I can add 6 to each of the elements in the array. So I'll do that for you instead. It's very useful to be able to check if an array, if any element in an array matches a particular value. So how many cats are in my array? How should I do that? Let's try sum. I want to count cats. So I have pets equals cat. That will count how many trues? 3 trues. Check that. 1, 2, 3. 1, 2, 3 cats. Do something a little bit weirder. Do some math. What's the average number of cats in this array? What would that mean? Watch this. NumPy.mean pets equals cat. What's that going to do? It's an array of Booleans. Those are 0s and 1s. It's going to do math on the array of Booleans. Math on the 0s and 1s, we can take the mean of an array of 0s and 1s, and apparently half the animals in this array are cats. That was a little bit weirder. Questions about that? No. Okay. If you have questions, ask. Okay. Let's do something even more fun. Let's assign is cat, that's a good name for a variable, equals pets equals cat. What is that going to do? That's going to take the right side here of this equality, the right side of this equality is this expression. That is going to be an array of Booleans. And it's going to say is cat should be that array of Booleans. Nothing special so far. Array of Booleans. Now let's do something special. What will the following do? Is cat times 2 minus 1. What will that do? Yeah. Give me an error. Now, that's a good idea. Python's like, no, I'll work with you. So what did it do? Yeah. Yeah, it said, you know what, that's the array of 0s and 1s, or true and false. If it was an array of 0s and 1s, I would go, well, 2 times the array of 1s and 0s, 2. I'll have a bunch of 2s and 0s. And then I subtracted 1. let's just do that in steps. So what happens if I just did this 2 times? So 2's and 0's, and minus 1. That makes sense? Parentheses here. So you think about it, all the trues became 2, and I took 1 off, so they became 1. And all the falses they were 0. 0 times 2 is 0. And I take 1 off from the 0, that's negative 1. So I took an array of trues and falses, I made it 1s and negative 1s. Why'd you ever want to do this? I don't know if you want to do this for this class, but in your future life, you might need inputs that are converted from 1s or negative 1s. It's how some people like to code true and false for various tools. So. Okay, so we can do math with our booleans. Any questions now? Keep going. All right, so applying functions to a row. We've already been using the dot apply method on our tables to apply functions to a few of the columns row at a time, right? You might have been wondering, well, can I just get a row? I can pull columns out of a table. How do I get a row? So we have a function, a method on our table, table.row, that lets me pull out a row. If I give you an index, you grab me the row at that location. Then a row it's actually it's a special kind of thing. It has its own things you can do with it. Like item lets me pull out a value in that row. So item 1 pulls out the second thing in that row. I can also say item and then the column name, and it'll pull out the value corresponding to that column name from that row. I can also, and this is kind of cool, I can apply things like sum, mean, all these aggregation functions to an entire row. And if it makes sense, if it's numbers, it will go ahead and apply those and do compute the sum. Yeah, so just to highlight this idea, so if I have now a table, T, and I say apply a function F, let's call it sum, that will just go ahead and say, you know what, take the sum function, just apply it to all the rows in that table, taking all of the columns, they're all numerical, and computing the sum of them. Questions? Oh, I'm supposed to do a demo. Oh, back to the survey. Okay, so I have the survey results here. I want to get row 0. How do I get row 0? What is row 0? First row. Confusing. Row 0. So that returns a row. See, it says a row. It's the row object. It just has the information on the first row. Let's give that a variable. So it looks like, there you go, there's our row. And then what is the type of this row thing? Some of you might have guessed. It is a row. It's a data science, that's our Berkeley library, tables, sub part of that library, and then a row. So a row thing in that library. Okay. Is that important to know? Well, it says what kind of things we can do with it. So row has some methods in it, things that we can do. I think the most important one I want to highlight here is item. So what will this return? It will return 2. Someone said 2. Good. Okay. Why did it return 2? Because it said get number 1, and that is, of course, the second element in this row. What's weird about rows, it has things of different types. So if I get 1, I get a number. If I get 0, what do I get? String. Right. So rows aren't like our arrays. They have different types. They're more like a list. They have things that are different types within the same row. Questions? Yeah. Yes. So I have a row here. So survey.row got back a row. You used can I use a method? So a method is a thing, is one of these functions attached to this row object I've got. So I've got this row. If I put period, these are the methods I can apply. So I'm going to do item. That's the one we're going to focus on today. That's a method, and it's going to get a piece of information from that row. I told you could do 0. In this class, we do that. And I noticed it's in the homework, it's in the lectures. As a data scientist, I'm appalled. You should not do that. You should say something like, year. Because what is 0? I don't know. That's way easier to read, right? I said, I don't want the zeros thing. I want year. Actually, I changed my mind. I want extroversion. That will be this. There we go. Right? So if I have the number 1 in there, you're like, what is 1? I have to go back and figure it out. But if I say row dot item extroversion, you're like, I know what you're talking about there. It's much clearer. Okay. We can do math on rows. What am I to show here? Okay. So I'm going to get row 2. Well, let's just make this row. That looks more like row 2. So here's what I'm doing. I'm taking the survey. I'm going to take just these columns. So now I get this thing up to this point here. This whole expression is a table. And I say I want the second row indicated by a 1. And I will save that to my variable R2. That's a row. It has extroversion, number of textees, hours of sleep. I can do math on this row. So I can do sum of row 2. What will that do? It will compute something. 13? Yes. So it just adds numbers. Why would I want to do that? I don't know. We'll see in a second. There's a reason we're going to this. All right. Questions up to this point? Let me just do one thing. What if I added year here? What's going to happen? What's going to happen here? Any guesses? Yeah. Did what it should do. It gave me an error because it doesn't make sense. I have a string in that array. So kind of bigger takeaway here. Python tries to be nice. That's why people like Python. If it can make sense of what your expression is doing, it will try to do that. If it can't, it should generate an error. If there's just no logical way to think about a sum, which contains a string, it will not give you an answer. Unfortunately, what I just said is not entirely true. Sometimes Python will be really too nice and go ahead and make things work that you didn't want to work. And that will be a bug. And you'll have to figure out why it was that Python did something you didn't expect it to do. Okay, I rambled. Any questions? No. Okay. Let me just clean this up so I don't accidentally post the wrong notebook. Okay. We did apply before, right? So you've seen apply. So I've taken extroversion, number of textees, hours of sleep. When we used apply in the past, we passed in additional arguments. We would say which columns we wanted the apply to be applied to. So we'd say sum, and then we'd list them. In this case, I've made a subtable, which has just numerical columns. And I'm actually not going to list the arguments because that would be annoying to write down all these columns again after the apply. So if I just give it a sum, it'll just take that sum function and just apply it to the whole row. This again will be useful if you want to compute aggregates of rows. We've been computing aggregates of columns in this class. Now we can compute the aggregate for each of the rows. So this is going to take the table of here. Let me just do this in steps. Okay, there's my table that I had before. And if I could say apply sum. This could be tiring, but let's try it. Could do this. Oh no, sum doesn't take positional arguments. All right. If I had written my own function called sum above here. Actually, I won't do that. No, I'll do it. I just started. Okay. So def sum 2, A, B, C, return A plus B plus C. Okay, so that's what we did before. I could say sum 2, and that works, right? That was I wrote this annoying function that I had to take 3 arguments, and if I decide I wanted a 4th argument, I have to make another function A, B, C, and so on. That gets cumbersome. See? So what is nice is that we don't actually have to do that. So if we're using our sum, we could do it numpy.mean, for example. I can apply any of these functions to the entire row. And it's going to take one row at a time and take the mean of that row and return a number. And that's the number we have here. So why would we do this? Let's try to motivate this a little better. So I have a pivot table. So let's review what I just did. I said I took my survey, and I wanted to make a pivot table where the columns will correspond to the various sleep positions. So on your back, on your left side, on your right side, and on your stomach. And the first column will be the hours of sleep. So this is hours of sleep here. So each row will correspond to a unique value of hours of sleep. Each cell in this table is the count of people who have 3 hours of sleep, rough, and sleep on their left side. 2 of you. I'm sorry. But sometimes you want the total over here. How would I get that? Let's try. So I'm going to add row totals. I have P as my table, so start there. Okay, so let's do this in steps. So I have P is my table. I'm going to add a new column. Actually, let's do this one step at a time. So drop. So I don't want hours of sleep in my total. I just want the total of these columns. So I'm going to drop hours of sleep. So this. Drop hours of sleep. Now, this is where I'm going to, here, just look at, so that's my little table, right? So I've dropped the hours of sleep. Now I want the sums of these. We just talked about how to do that. So sum, sorry, can't do sum. I want to do apply, and then I'll apply the sum. So that will take the sum function and apply it to each of these rows. I have an array, but I want to put that back on my table. So how do I do that? So I can go, P with column. I got, let's put these back together. Easy to read. I'll call this column totals. Total. That's it here. Okay. And now I've added a total column, which hopefully is the sum. 1. Yep. So 1 plus 2, 3 plus 1 more is 4. Right. So I've made my totals. Questions? One more time. Yes. All right. Let's go back to that. I said, take my table P, drop hours of sleep. Now remember, our philosophy in this class is we don't ever modify stuff. We make something new. So I said the pivot table, drop hours of sleep. That means create a new table without hours of sleep. The original table P is unaffected. So P still has hours of sleep. So I cut out hours of sleep. So now I just had a table that looks like this little subtable of these 4 columns here. And I say sum, apply the sum function to each row. So, and that computed this array right here. And I said, you know what, let's put that back on my table P. So P with column total, called total, and then this array that I just computed here. Questions? How's online going? Are there lots of questions? Okay, good. All right, so once more, and that confusion is very warranted. Apply is a cool function. So we've already showed you, I can say apply, take one of your functions, and then I give it a list of columns, and it would say, for each row, take just the list of columns, pass them in that order to the function I just created, and then take whatever result and put that into the output. And that would go once for each row. That's what we did before. Today, we're like, well, sometimes you just want to take the sum. And I don't want to write a function that sums 2 things and sums 3 things and so on. So instead, I give you a function just sum. I give you no other arguments. And that says, for each row, take sum and just apply it to that row, computing a number, 1 for each row, and return that result. Okay. Yep, let's pick up the pace. Okay. There's a cool way to do this with group by and join, with group and join. I recommend if you want to more practice with group and join, try that. I'm not going to do it now. Okay. Now we'll get to some fun stuff, control statements. Control statements. All right, so control statements, let me just build this in actually. There we go. Okay, so control statements are a way of controlling the execution of your code. Right now in this class, we've been writing sequence of statements in our cells. We put, expression, 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 and the computer goes, run that expression, run that expression, run that expression. But sometimes you want to go expression, and if something is true, run this. But otherwise, don't run that piece of code. Keep going. That will be our if statement. And other times we'll say, run this expression 1,000 times. So take this expression and do it 1,000 times over, or 10,000 times over. That'll be critical to simulation. That is what the for piece of syntax will do. So these are two keywords in the language. You can't name your variable if, and you shouldn't name your variable for. Can't do it because they're built into the language. They allow us to do this control flow. So let's look at some examples. Conditionals. Okay, let's make a variable x is 20. Here's our first conditional. So here's how to read it. So if x is greater than or equal to 18, do whatever is in this indented block of code. So let's run that. X is greater than or equal to 18. Yes, so it runs that. So let's put another block of, another piece of code here. Print something else. Cool. So I printed two things. So two things happened. What if I make x like 5? Now what's going to happen? Nothing. Right? Let me print. This can run. Okay, that gets to run. And also print this can run. This also. See what's going on here. If statements. Questions? So I've now controlled which code runs based on my conditions. Make this 20 again. Now you get more text. Okay. Let's walk through an example about drinking. So if your age, say x is an age, is greater than 21, you can drink. What is the value of x? Oh, this character cannot drink. All right, so can you drink? We printed that. If x is greater than or equal to 21, you get some extra stuff. Otherwise, you don't, right? And so, sorry, what is here, I will not run if x is less than 21. So the output of this is this expression. These are all skipped, and then these two expressions are run. What happens if I change x up here to be 21? What will this do? What will the value of x be at the end of this? What will it print on the last line? Take a moment and think about it. Maybe talk to someone. Also ask the person if they're confused. Go talk quickly. How come no one talks? Talk. Like, man, I know this is a little dry. Okay, what is the value of x? So I said x is 21. I'm going to run this expression. The value of x is 0 because code was run, and I changed the value of x. So I went inside the body of that. And that assignment remains true outside of it. Once I do that and make that change to x, it is now the new value of x. Questions? Okay. Next piece of syntax. So I told you about if, and I sort of started to include this other thing. If something is, if I do this, but if I don't do that, I should do something else. So there are two pieces of syntax that we're going to introduce now. One is else. This one kind of makes more sense. So let's actually just cut this for a second. Okay, that says if x is greater than or equal to 21, print you can legally vote and drink. Else, print you can drink milk. Okay, so either of these two things will be run, but not ever both, right? That makes sense? Just as one more, if I do this, that's different, right? That means the first thing will maybe be run, but the second thing will always be run. But I don't want that. If you're greater than 21, you can drink and vote. If you are not greater than 21, you can legally drink milk. Okay. So only one of those two outcomes will happen. That is what the else does. So once more, syntax is if, and then some Boolean expression, then a colon, that's important. Then this next thing has to be indented. Python really likes its spacing. Use spaces, not tabs. I've indented this. Everything that remains indented will happen in this piece of the code if x is greater than 21. In fact, I have to keep everything indented if I'm going to have an else. Then the else is not indented, goes back, lines up with the if. Else has a colon after it, and the thing I want to happen in the else. Everyone sees this. You'll always see that last line, right? Now you're like, huh, but there's this 18 business. This piece of code will not work. This piece of code will work. This is not English. Like I said, computer scientists cannot spell. This is else if, but that's too many characters as if. So else if is just elif. Don't ask me why. I don't have a good answer. Just you can't spell. So else if is elif. So if this is true, do this. Otherwise, if this is true, do this. Otherwise, just do this. Got it? What is the value of x presently? X is 0. That's unfortunate. Let's make x 18. You can legally vote. Everyone else sees this. Everyone sees this. Okay, questions? So behind. Yes. Can you use elif twice? Yes. Elif x is greater than equal to, is that true still in California? 16. Print. You can drive. Right. Let's make you 16. Of course, you can, yeah. And leave your vote. Let's run this. You can drive. The order in which I do these things matters too, right? So if I make this 16 first and this 21, what's going to happen? It's going to check them in order. So it goes, well, if x is greater than 16, go ahead and do this one. And then I won't look at any of these other things. Got it? So you only get one of these paths. So you enter here, check this. If this is true, done. Go to the end. Not true, check this one. This is true. Go here, done. Jump to the end. This is confusing. Can be a little confusing. All right, we're going to use this. So let's make some functions. I'm going to skip this functions. It's not as fun. Let's put these pieces together. So we had this trips table, which is, I believe, ride sharing on bikes that we were playing with on Monday. Here's 3 rows from that table. I want to make a function that is going to return whether or not this is a round trip. I'll make sure I write this function correctly. So I have this function, trip kind, and it says start and end. And it's going to be a round trip if start equals end. I made a mistake. Start does not equal start equals testing equality equals end. And I want to say, in this case, I want to return round trip. And then otherwise, else, return one way. Okay, so trip kind, the way it'll work is it'll say if start equals end, it will return round trip. Otherwise, it will return one way. Pretty straightforward. Questions? Let's run it. So now I get to use my apply function again. So one more example of apply. So trips with column. Let's add a column is going to be trip kind. And now we'll do an apply. So I'm going to say trip. This is plural. Nope, it's not. Okay, trip apply. Here's another use of apply. This is the apply you've been using in the past. So I'm going to say trip kind. But this time I only care about 2 columns. I want the start station and I want the end station. Very good. And this is saying take the trip kind function, apply it to each row, but only look at the start station and the end station. and pass those into the start and end in that order to that function. This will return a function of, or return an array of what? This whole thing will return an array of, I don't know, let's check actually. Oh, I didn't want to do that. What is that? Array of strings, right? Took the function, applied it to each row. Function returns a either round way or round trip or one way. So I put this in the trip kind. Now I've added this trip kind column to my table. This is a cool pivot. I'm going to skip this again in the interest of time. Questions at this point? Yeah. Good question. Start and end. Where did that come from? Okay. So I have this trip kind. I created a function. So let's walk through this. Def means make a function. I shall call this function trip kind, and it's going to take two inputs, start and end. Those are the inputs to the function. And then inside of this function, so this is inside of this function, what am I going to do? I start and end will have values when this function is invoked. And I say, well, start, does it equal end? And then do something. When I do this weird piece of code here, or here, so I say trip.apply, trip kind, it says take this function. I didn't invoke it. I didn't pass in arguments yet. I just said the function itself, pass that to this apply thing. And then this apply thing says, okay, no problem. I'm going to, and I'll show you how to do this in a moment, hopefully, loop over each of the rows in the table, one row at a time, pick up the row, pull out the start station, end station, and pass those two values into my function. And the function goes, cool, I got those values, does the logic, returns a string, and that string is appended to the array that I'm building out. And then that is what we see. And now I will show you how to do the for loop and the append. Oh, Professor Sahai is going to kill me. I'm so behind. Okay, random selection. So we are going to use a lot of randomness in this class to simulate things. It's actually a really powerful tool in data science and actually in computing in general. Our first foray into randomness is going to be the choice function. So this is going to select uniformly at random with replacement from an array a specified number of times. So you say np numpy, it's a library, random, a whole bunch of different things inside of random. We're going to use choice today. Choice, pass me an array or a list, actually, anything, array or list. And then the number of things you want to, number of times you want to sample from that with replacement. Let's do it. Okay, these are my mornings. Let's try np.random.choice mornings. Let's take one sample. Wake up. Cool. If I run it again, sleep in. Run it again. Wake up. Sleep in. What's the next one going to be? I have no idea. Sleep in. Okay, cool. If I didn't say one, Python's like, I get you. You just wanted one thing. I'm just going to turn a single element, not even an array, just a single thing. So I can keep running this. I can run this as many times as I want. It's going to be random each time. I can also do something like this. I want to draw 7 of these samples. So make an array of 7 invocations of that. So call it 7 times. If I run it again, will I get the same values? Maybe. I don't know. It's random. Just drawing 7 things from this array with replacement. Questions so far? Okay. So these are arrays. I can do all sorts of things I would normally do with an array. One thing to think about is if I do an assignment, morning week equals this. What is the value of, let's do this, of morning week? Cool. If I run it again, will I get the same thing? Yes. Why? Because I assign the outcome of this random thing to an array. So this is just an array now. It's the same array every time I run it. So if I take the sum, I can compute, this is, a sum of a Boolean expression. So morning week equals wake up. Apparently I wake up 4 days in my week. That is not true. And I sleep in, I have kids, so never, but in this case, I sleep in 3 days from that random sample. I can run that many times over. It'll always be the same thing. But if I do this, and this, and this, I wake up more often, and this, sleep in less. Questions? All right, I'm going to keep going because I really want to get to for loops. we're gonna play a game. So this is we're gonna roll 2 die. If my die lands with a higher number than your die, I get $1. If you get the higher number, you get $1. And if we both have the same number, it's a tie. No one gets any money. Okay, so let's play that game. So I'm going to make a die. It has numbers 1 through 6 on the faces. I'm going to roll it once, get a 5, roll it again, get a 1. So I've now made a way to simulate a die. Okay, now I want to simulate one round of play. I'm going to paste this in because I'm behind, and then we'll talk through it. There's a typo in my formatting. Okay. All right. So I'm going to make a function that simulates one round of play. The way it works is my role will be one play of this game, one roll of the die. Your role will be another. And then I have a nice if statement. If my role is greater than your role, return 1. Otherwise, if my role is less than your role, return -1. Otherwise, return 0. It's my function. Let's play the game. Who wins, me or you? We don't know. Oh, it's a tie. Very good. I lost. I will play until I win. Okay, I won. Right, so I keep running this. Every time I run this, I get a different outcome. Or I get another random outcome. Okay. So that is simulation. That the first piece of simulation. Please don't run away. I have 1 minute. It's enough to teach you for loop. Okay, 4 statements. These are really powerful, like big piece of the language. So I'll try to do it quickly. Let me have a piece of code here. So this is the way to think of a for statement. So a for statement looks like this. You have the word for, then you have a variable, and this is going to be anything you want to call it. Often we call it the letter I or X. And it's saying for X in, this is some array, do this thing inside the body of this for loop after this colon. And that thing will then run however many times this array with the item taking on each of the values in that array. So let me show you what that looks like. All right, so I made an array of cat, dog, and rabbit, and I say for pet in array, print, I love my pet. So now that piece of code ran 3 times, it printed 3 times, pet took on the value cat, then it took on the value dog, then it took on the value rabbit. That is a for loop. Another way I might use a for loop is I'm going to take x equals 0. I'm going to say I, again, I get to pick this, whatever I want this letter to be. I've chosen I for this case. That's my variable. It's going to be in a range from 1 to 4. So that's 1, 2, 3. And I'm going to say x equals x plus I and print the value of x. What is the final value of x? 4. The final value of x is 4. Any other guesses? All right, I'm going to run this, and then I'm going to have to steal some time from Sahai. Professor Sahai. Yeah, so x got to take on the values of 1, 2, and 3. Sorry, I got to take on the values 1, 2, and 3, and each time I updated x, so x was initially 0 equals, or x equals 0 plus 1, so it's 1. Now x is equal to 1, so x equals 1 plus 2, 3. And now x is equal to 3, 3 plus 3, I is taking on 3, is 6. That is my sequence of operations. All right, that is end of for loops. We will pick up a little bit of this on Friday.